Alrighty, let's see what's happening. Let's do this. Pop out chat. Let's put this fella. Ha, a little long time no see. Edit docs, lock docs, custom browser docs. Max, my friend, good evening. How are you doing? I'm doing really well, man. Really well. Let me just, as I'm abroad, it's a little bit different setup here, if you remember, right? So let me just, yeah. Let me just, what am I trying to do here? I'm trying to log in with some email, right? Programmer network. Give me 2 seconds. So I guess I'm gonna say hi at. So it's not a new setup. It's not a new setup, Max. I am abroad in Balkans visiting family. This is my apartment. We bought this apartment 7 years ago, me and my wife. So I'm now in this. This used to be my office 7 years ago, 8 years ago. So now we are basically there. So I'm gonna leave this setup in here because yeah. So next time when we also come, I have all of this thing, all of this stuff in here, right, as well. Give me just one moment. I need to set this up. And YouTube, good evening, YouTube. I'm just give me a second. Let me just let's just make sure that I set this up properly. So right now, I don't know why I'm seeing a video in here that makes 0 sense. I shouldn't be seeing this. So let's try this once again. YouTube, apply. And then we go docs, I guess, custom browser docs. I suppose it's supposed to be here now, the YouTube chat, custom browser I see it, my bad. So YouTube. Okay, great. So now we have that chat there as well. And what I'm actually going to do, probably I'm just going to open up my laptop here just as I did yesterday. I should have actually set this up before I started the stream. I'm actually sorry for that. Just give me 1 second. All right, so let's do this. Nice. Beautiful. And actually what I'm going to do, Jesus Christ, man, come on. Super. Okay, great. All right, great. Super. So I think that should be fine. Give me actually 1 second here. And I suppose you should be able to hear me pretty well, right? Yeah, all right, cool. What the hell is going on, man? Come on. So annoying. All right, cool. Great. So we have that set up. We can start views occurring to viewers. Okay, so I guess we can close this. We can close this here. So yeah, so today's stream we continue with Golang, with Go. Obviously learning it, and if you watch the past 2 streams, last night we've stopped by finishing this. We didn't do the exercises though. And yeah, so now we are basically we might continue here, or we might actually start building something. So it's a good. I'm not actually sure. Let me just skim through this very quickly. Yeah, exactly, right. So this is quite important. A lot of this stuff. Yeah, this section is like super important. Our saga continues, exactly. I think yeah, this section is like super important here. So I think we should just maybe continue this section with the bottom up, because there's a lot of stuff here that's very important, right? So maybe we should just as the last thing do this section maybe, and then start building something. But I think this is very important, some of these things that we should go through together. Yeah, I don't actually know, but I think we should maybe try doing that. Give me just 1 second. What is this notification I have here? Is it? I don't know why is this crap giving me notifications when I muted the notifications. It's so frustrating, man. All right, cool, great. So yeah, good evening, everybody. And today we're gonna continue with the Go journey. Somebody gave us this resource last night, so we might look at this as well. And we're going to continue just maybe a little bit more with this very bottom-up approach. Go through a few other things that we didn't go, obviously, past 2 streams. And then we'll have to start building something. We'll have to start building something that might not be an API initially. So what I'm actually going to try to find is, I remember maybe 10 years ago when I wrote nodejs for the first time, there was something called the Node School, and this Node School was pretty cool thing back then. It's still cool. This was one of the first tutorials on Node.js, and it was really related to doing system level stuff with Node. Writing to a file, reading a file, creating a file, and all sorts of things, right? So I think once we've finished this thing, here we're gonna try to see if there's some alternative to Go like this, right? So something where instead of just starting to build an API immediately or something like that, right? We'll try to see, if there's something like this. Of course, something practical as well, but just using maybe, writing some files, reading the files, and a bunch of other stuff, right? So we'll try to find something like that. Okay, so today we're gonna continue with this thing, because I think those 26 points here are very important, right? So let's start already. So let's start with the methods. Go doesn't have classes, as it says. You can define methods on types. And it's a little bit weird they're calling them methods, because again, method is something usually that's called, it's a function that's usually part of some class. But yeah, I guess we can still call them methods if they're part of some custom type, or we'll see that in a second. Methods is a function with a special receiver argument. So AR, my friend, good evening. The receiver appears in its own argument list between the func keyword and the method name. This example, the absolute method has a receiver of type vertex. So let's continue where in the same fashion we did last night. Yeah, so as you can see, basically now we're talking about extending. I hope you don't mind me asking. I missed the previous streams. Well, I mean, I've been learning and relearning Go for many years, and I've been using it in most of the companies, right? I think the Go is a beautiful language, as I said in previous 2 streams. It is the language of the infrastructure. It's the language of Kubernetes. It's the language of Docker, and it's just most likely the language when it comes to building, let's say, APIs and services. There is no better language that achieves that than Go, right? There's no such language, and it's generally a very simple and very well-defined language. It's a beautiful language, so that's why. That would be some of the reasons, right? Yeah, so I hope that suffices the answer. So okay, so let's talk about methods, right? So let's talk about methods. There isn't really much of a difference, but let's still talk about it. So Go doesn't have classes. Thankfully, I'm very happy. But you can define methods, so it's good that Go doesn't have classes. I'm not a fan of classes of that. A method is a function with special receiver argument. The receiver appears in its own argument list between the func keyword and the method name. So this might be a little bit strange, right? Numinex, my friend, good evening. Good to see you, man. So as you can see, when we want to define a method on some type, It can be a custom type as well. It doesn't have to be the struct. How do you memorize the syntax? What is the easier way to memorize this? The easier way to memorize this is to remember that you put a receiver argument in between the func keyword and the function name. So that is the easier way to do that, right? So in simple words, pretty much this sentence kind of nails it in that sense, right? So if you can't memorize the syntax, the simplest way to memorize how to write a method in Go is to remember, well, I just need to put another set of parentheses with some arguments in between func and the function name. So this is how you declare a normal function in Go. So you say something like this, for example, right? And then the only thing we have to memorize when it comes to function receivers or the receivers is that in between func and your function name you put a actual receiver, right? Yeah, exactly. So because trust me, you know, it's a little bit annoying to memorize this detail. It's not a syntax that's very intuitive. So, but the easiest way to memorize it is that receiver stuff goes in between. So the best way we can approach this together until it gets into our muscle memory is that whenever you want to write a function receiver, whenever you want to write a method that's a part of some custom type or a struct, write a normal function and then put the arguments in between here. That's the easiest way to do, right? So write a normal function that we know how to do in Go. We can memorize that easily. And then additionally, write the receiver here, right? So that maybe we can approach it that way until it just naturally starts, right? Let me just, give me 2 seconds. Let me just switch the music. So let's go, let's play Bob Marley. I don't know. All right, so yeah, so basically, yeah, so again, just to recap on this one, we are using methods in nearly every language. You're using methods in classes in C++, in JavaScript, in Ruby, in many languages. It's and a method is basically just a function on some object, usually, right? And in Go, since we don't have classes, it doesn't really matter. It's telling us, hey, well, you can still declare a method on a struct, for example, or some custom type by creating a function receiver. And then we just learned that, yeah, the easiest way for us to memorize this, declare a normal function and then add the receiver arguments in between the function name and the func keyword, and then define the right. So basically, what is happening here? Well, we are here in this context. Here we're defining a method called abs on this struct vertex, right? So that's why we can say v.abs. So we create a vertex, and this v now has, right? So if we are to simplify this example a bit, because they keep using this annoying vertex example, you can say type person struct. And it doesn't even have to be a struct, right? You can create your own custom type. You can say type, type whatever, name string, right? You can also initialize it if you wish, right? But we're just gonna do this. And then here you can say, and let's do it as we said. So we're gonna say func, and I'm not gonna create a function receiver now. So I'm gonna say, print name, right? And then here we can add a function receiver, right? And we can say n name, and you can do something like this, right? I mean, you can omit this; it doesn't really matter. So this is a little bit different now, right? Exactly. So you can see we created our own custom type called name, and we've added so now I can say here. I mean, this example doesn't really make much sense. I just want to illustrate that. But so now, as you can see, name is John. Name.print name, right? So if you run this, we're gonna get John, right? So as you can see, we've created our own custom type in Go. It's called name, which is just a string. I mean, it's still a string, right? So technically, name, even though it's a custom type, it's of type string, but it doesn't matter, right? So for example, a good example of this would be using some gaming terminology. Let's imagine that we wanted to have a type of a weapon, right? Let's imagine we are building a video game or something like that, right? Usually using gaming terminology helps people understand. Let's imagine that we had something like this. Bear with me. We say type player struct, and then player has a name, and player maybe has a health, right? This could be a potential useful example. But we can have another very simple type. We can have type, which is not a struct, but it's going to be type weapon, right? Or whatever, which might be just a string, right? Not an enum. Enum would be better or whatever, right? So you can say here weapon, right? And here you can say, well, we can say weapon, for example. We can say this that the weapon that a player has, just the arbitrary example, is of type weapon, right? And then you could, of course, add the custom methods in a weapon, right? You can say, for example, you could say func, and then we can do something like this, right? This would get us the actual weapon. So the point is, right, is that now if we create a player, I say here a p player, right? And then we actually, this is quite useful. So you can see now I say player is of name Hans, health is 100, and then the weapon is a sword, right? So technically weapon can be anything now, but we know that if we hover over this, we can see that the type of this is a weapon, right? So it's kind of easier to follow through, right? You have your own type, which is a weapon, and you can then confine it. Maybe you can almost make it a struct if you wish, right? You can say that the weapon has to be one of the possible things, right? Go doesn't have enums officially. You can fake this a little bit if you wish. You can kind of create enums. Can you do something like the func a string print and print the string? We'll talk about that Numinix soon. I think they also have it in the official tour of Go. And then you can see here that we can actually go and say, also here we can say now we can say p dot weapon dot string, right? And you can see now, in fact, you can see here basically we created a receiver function. We created a method on a weapon type, and this basically just prints the weapon itself, right? So you can see here we say p.weapon.string, but this is a different subject. But generally, yeah, we have our own custom type here. We have a struct, again, that we discussed last night. And you can see I can create a player, and I initialize the player with a weapon, which is sword. And this weapon, basically the sword, is of type weapon here, right? So you can create your own custom types. Hans, exactly. All right, cool. So that's basically methods, right, in Go. There's more stuff we can discuss, right? Hans the flamethrower, exactly. Look who is here. Look who is here. Cedric is here. Okay, give me a second. And of course now, we also discussed pointers last night, right? Well, sometimes the receiver is also going to take a pointer, not a, right? But that's beside the point. That has nothing to do with this in a way, right? Because do you pass a pointer or a value? Well, that's a different subject, and we discussed that last night. So sometimes you will, in fact, pass a pointer to something. Sometimes you will pass, and that depends what a method does, right? So if you wanted to create a method on the player that mutates the actual player, right? So then you would obviously create a function that takes a pointer, right? So you can say here func, you could say I don't know, p player. Yeah, as you can see here, yeah. Even though, yeah, here we are in fact passing a pointer, right? But what we could do is we could say, set health, whatever, right? Something like this, right? And then here we could say p.health. And then here we can pass health, which is an int. Something like this, right? So in this context, it makes sense. I will totally start using this from now on. It sounds actually quite silly. Yes, I agree. So you can see now we can say p dot set health, but we'll learn this together as we use Go more, right? So we'll learn this more, right? And then if we go back down here, right, we say print and then we say p, right? And we obviously I don't know what the hell is happening here with FMT, with missing FMT, but that's what it is. That's what it is. Yeah, there we go. So as you can see now, we have in fact changed the health of that player. So we have mutated the health of that player, right? But it's a different subject. All right, so that's methods really. Methods are functions. Remember, a method is just a function with the receiver argument, right? Kind of shallow thing to say, because if you say someone especially who's a beginner that the method is a function, that doesn't really mean a lot, right? But I guess so they're missing a little bit of context here. Like some more context would be important, right? But in simple words, what this means is that hey, Go doesn't have classes, right? So technically, there's no special behavior. There's no context of this in that sense and stuff like that, like you would have in JavaScript, right? So receivers are just functions, methods are just functions with this extra receiver thing, right? That's really all that there is. That's how you attach some sort of an object to it. Method continued, you can declare method on a non-struct types too, and that's what we just did, right? So they're saying, hey, well, you can you don't need to it's not just the structs that you can use the methods on. You can use it on your own custom types. And that's what I actually showed you. So it's good that right. So yeah, that's what they're doing here. They have their own type called myFloat, right? And as you can see, they have a function receiver here, and then they're doing stuff. Chica, my friend, good evening. So yeah, so not much to say, right? So we can define methods on any custom type or the structs as well. Pointer receivers, you can declare methods with pointer receivers, and that's also what we just did, right? This means that the receiver type has the literal syntax t for some type t. Also, t cannot itself be a pointer such an int. For example, the scale method here. Let's take a look at this, right? So that's also what we just did. So as you can see, they have two function receivers, right? This one takes the actual value, doesn't take a pointer. So this takes some vertex. Again, shitty example with these vertexes and stuff. They should use less math-oriented examples, just a player or whatever. But then here we have one where we actually mutate stuff. So you can see here we're going to take the vertex and then we're going to mutate the x and y. So when they call this vScale here, and then they pass the 10, for example, right, which is this thing here, even though it's strange that it's a float. Yeah, I mean, it's again, for me, it's about the art of education is making sure that people understand things. The art of education isn't to you as a presenter or teacher to look smart, because people don't come to you for education because they want you to be smart. They come for you to education for them to become smart. So in simple words, I never understood the point of view. I remember when I was at university 15 years ago, right? More than 15 years ago, actually. I think, yeah, more than 16 maybe. It was the same, right? Just a bunch of integers, numbers, floating points. Like, man, why? I mean, the point of education is to simplify things for people. So use more, right? Good evening, Billy. So yeah, you get the point, right? It's like, yeah, it's you know, any other more human readable thing is like doing this sort of stuff is not something that I would use to yeah. But anyway, so we just did this. So of course, as in any other language, including JavaScript, in JavaScript we don't really have a choice. If you remember if we're passing complex types, reference types, we always pass a pointer in JavaScript. In Go, you have a choice. If you remember from last night, you can pass things as a value, or you can pass the pointer and then mutate the actual thing. So we don't have to create copies like we have to do in JavaScript in order to not mutate. So in JavaScript, if you pass an object, yeah, you don't make a copy, you will mutate the original object. And JavaScript, as we said, for the most part, we want to keep it immutable. Okay, pointers and functions. So let's see what's happening here. here we see the abs and scale methods rewritten as functions. Again, try removing the asterisk from line 16. Can you see why the behavior changes? What else did you need to change for the example to compile? Let's use this little thing. So as you can see here, they're saying, hey, well, you know, we're no longer creating function receivers or methods on the struct. We are now creating just normal functions. And then we are just calling these normal functions. We're passing a pointer here, and we're passing a floating point number. So yeah, so far so looks fine, right? And then we're creating a vertex with a x and y 3 and 4. And then we call the scale, we call this fella here, and we pass an address of this vertex, and then we pass the value. So let's see if we do this, and then we have the abs. So let's see what happens if you run this. We get 50. Okay, so let's see. And did I actually save this? Okay. And also let's run it here. They want us to remove the okay, I see. So let's remove the asterisk, the pointer from here. Let's remove the v. Well, obviously we can't now. It's gonna have a different output, right? So basically what they're trying to tell us here, so this is now basically again enforcing the idea of pointers, right? So even though we're discussing certain different subjects now, they're saying there's a vast difference, right, in the output of this program now. If we remove a pointer, we're no longer mutating the original vertex in this context, right? So that's what they basically, what this very small exercise is about. If you remove the asterisk and the ampersand, you're basically not gonna mutate the object. So essentially this is actually good. So you can see how even the tour of Go is slowly introducing pointers, right? So that's great. I think hopefully that's clear. Method and pointer interaction. Comparing the previous two programs, we might notice that functions with the pointer argument must take a pointer. And this is what they want us to check, right? So obviously if we remove the asterisk from here, we cannot pass an address of a value, right? Does Go best practice to mutate? Well, no, I mean generally in languages that have pointers, you have the pointers for the sake. I mean that's a very hard question to answer absolutely, right? So it depends, but obviously unlike JavaScript, as I discussed last night, right? Unlike JavaScript, right? You definitely don't want to make copies as you would in JavaScript, for example. So for sure you will mutate a lot more than you would, let's say, in the JS world, right? Okay, so let's see what are we doing. Okay, while methods with pointer receivers take either a value or a pointer as a receiver when they are called. Okay, vertex scale, yeah. So basically they're discussing what we just saw in the previous example. Let's get back here. So we have a function receiver. We have a normal function. So this is a method on the vertex. This is just a normal function that takes the pointer and the floating point number. And then here in the main, we create a vertex v. We call the scale with 2. Then we call the scale function. Yes. So you can see the difference, right? So I think what they're trying to portray here to us is that when you call the actual function, when you call a method, you're basically omitting the actual reference to anything because the reference itself is the object, right? You get what I mean? So you can see, for example, here when we call the scale, we say v.scale. And you're probably wondering, well, what about this function receiver stuff? What is this? Well, that thing is the actual object or type in this context on which the method is called, right? So here, that's the vast difference here. And the difference when calling a regular function is that you obviously have to pass the address of the object in this context again, and then the value itself, right? So can you still mutate values contained inside the value passed by value? Well, I mean, when you pass something by value, the only thing you can do in that function is return some computation or expression from that, right? Struct inside. I don't. Yes. Okay. Somebody said yes. Methods and pointers in direction 2, the equivalent thing happens in the reverse direction. Functions that take a value argument must take a value of that specific thing. So let's see, let's take a look at this together. So let's come here. So we have, again, we have function receiver that doesn't take a pointer. We have a normal function that also doesn't take a pointer. And basically they're saying, well, so it's reversed. If the function isn't taking, so past two examples are pretty much this. If a function accepts a pointer, you have to give it an address when you're calling the method or whatever. So when you're calling the function, if the function isn't taking a pointer, you can't pass it an actual address, right? So it's essentially just saying, well, you can't pass things which the function isn't expecting, right? So you cannot pass a pointer now here because it's not expecting it, right? That's really all, I guess, that it's saying. So here we have v. We call the abs, which is just, and this is going to return some square root, whatever. And then we have this guy, which is going to print that. Then what do we have here? We have the vertex, and we have basically the address, right? And then here we do the dereferencing when we're passing this, basically. So in simple words, here we're passing the value. We have to dereference this so we can pass the value to the abs, right? If we pass the p, that would not work because actually you can see cannot use p variable of type vertex as vertex value and argument as well, right? So it's saying, hey, well, this function isn't actually expecting a pointer of any kind. It's or an address. It's expecting the value, so it's in reverse, right? So we have to dereference this so we can get the actual value, right? That's what it's saying. There are two reasons to use a pointer receiver. The first is so the method can modify the value that its pointer points to, obviously, right? That's going to be probably the rule for most things. The second is to avoid copying the value in each method call. This can be more efficient if the receiver is a large struct, for example. In this example, both scale and abs are methods with receiver type vertex, even though the abs method needn't modify its receiver. In general, all methods on a given type should have either value or pointer receiver, but not a mixture of both. So basically what they're saying is like, hey, well, in certain areas, it's not just that we pass a pointer because you might modify something. It's also so we don't create a copy of the argument value, right? So it's also more memory efficient to pass a pointer. So basically it's like, hey, sometimes you're going to pass a pointer, but you might not actually change anything in your function, right? So if we take a look, they probably have an example here. So let's see, we have a vertex, we have a function receiver with a pointer, we have a normal function, no, we have another function receiver, actually, both of them, right? And I suppose the abs one, you can see they're calling the abs, but the abs isn't really modifying anything, it's just returning the value of something, right? And the value of this is that, so basically, this is that's just standard method on a struct. In this case, think of it as a class that computes something and returns the value, right? So it makes sense. It makes it convenient to call a method on an object, for example, right? So that's what we're doing here. So that's why we're also passing a pointer here, so we don't recreate. So it's more memory efficient, basically, right? But you can see this is not mutating really anything, right? We're not setting any extra y in this context. So that's actually a good point. So if we run this program, so not much here to say. It's just printing values before we call the scale and then printing them after we call the scale, right? So this is an interesting one to remember, right? This is an interesting one to remember because, again, yeah, sometimes we will be passing a pointer for other reasons than just modifying something in a type, right? And this is another interesting thing. In general, all methods on a given type should have either value or pointer receivers, but not mixture of both. I guess, I don't know if this is an idiom or idiomatic Go. Again, some better Go developers here can claim that. But basically what they're saying is that, let's say that we're implementing a small library, we create our own structure, and we want to build some kind of couple of methods on it to, right? They're saying either make them all take a pointer or none, right? So don't mix both of it. Is this what the Go community does? I don't actually know. And good evening, Silent Dat. I don't actually know. We'll learn in time together. But that's what they're saying. They're saying, hey, either, here we have a scale, we have abs. Can you lower down the music? Of course I can. Let me know if it's fine now. So that's what's happening. Interfaces. Oh, wow. Interfaces. This is a big one. Interfaces are a big one. Interfaces are a huge one, right? And I don't think that this is going to cover interfaces. Interfaces are such a huge part of Go that we'll not learn everything about interfaces. I don't even think that I know everything about interfaces in Go, but I know that interfaces are a big thing in Go, and so we'll cover this, and then as we build software together, hopefully we can start building actually something today. We'll cover interfaces more as we build things, but so let's go in with it. So interface type is defined as a set of method signatures. A value of interface type can hold any value that implements those methods. There's an error. Okay, so let's read code and let's fix code, right? So let's go here and let's do this. Let's see what we have. There's a bunch of stuff. There's a main thing here. Then there's some stuff here. Did I let's just make sure I copied the right thing? I did. Okay. So let's read this code together. Let's debug it. So where is the point of execution? So we have some functions declared here and some vertex. Okay. So we have a var absr. Basically the A is type of an interface absr, and this interface has abs method on it. We're going to discuss this in a second. Then we have another variable called f, which is my float, which is a custom type defined, and then we have a vertex. Then we have an A pointing to f, which is basically my float. I see, okay. And then we have A pointing now to memory, to the memory address of v, and v is vertex, okay? The following line, v is a vertex, not vertex, and does not implement absr. So what do we have to do here? So how do we fix this, right? So the v thing, this guy, which is a vertex, which is somewhere. So let's just restructure this because it's a little bit difficult to read. So I'm just going to put this stuff somewhere around here just so I can read it a little bit easier. So it's a very shitty example, so we're going to improve this in a moment. But yeah, so we can't reassign A to V because the V isn't implementing a method defined in this interface. This interface here, absr, and we're going to talk why ER at the end and stuff like that. But yeah, so we I guess to fix this, that's what, I guess what they want us to do. We need to, let's try something like this. We need to pass a proper thing to, we need to assign a proper thing to A, right? So is this, yeah, it's a little bit like, yeah, shitty, right? And actually, does this actually fix it? So no, that's not actually what we wanted to do, is it? But because what is in the following line, V is a vertex, not vertex, and does not implement absr. So what do they want us to do here? Vertex does not implement absr method. So I guess, I suppose that we're supposed to somehow So let's see what okay, so I just want to see if there's like if there's more to this that we read. Otherwise, we'll solve it at type. Yeah. Okay. So let's go back here. Let me read the comments. I think Vertex should not implement abs method with pointer receiver. Well, it's a little bit confusing. What exactly are we supposed to fix here, right? Like what is broken? Because I mean, if I comment this shit out, right, we have asterisk vertex, a pointer vertex implement absor, right? So are we supposed to not make it implemented, or are we supposed to fix this, and fix it how, right? Because so we have the interface here, that absor interface, and A is of that type, right? No, that's not the problem, no. Okay, that's the problem. Yeah, exactly. So yeah, I cannot use V, an absor value in assignment. Vertex does not implement absor method. Abs has pointer receiver. Exactly. Yes. So I get that, right? I mean I get it. So that's the main confusion, is like, are we supposed to do something about it? But as you're saying, we're not supposed to do anything about it. We're just supposed to, I guess, understand why the error happens. And the error happens is because of this fella over here, right? If we remove that fella, for example, right, then this would actually be gone, right? Or to say this is also why this line works, right? Okay, I get it, right? Okay, but this is a very poor explanation of interfaces, right? I think this is very shallow. This is not sufficient. So let's stick to this a little bit, but let's see, just before I shit on this, let's just skim through to see if there is an actual explanation. Type implements an interface by implementing its methods. There is no explicit declaration. So it's not a great thing, right? So let's just skim through before I crap on it or whatever, right? So this is not a first great example of interfaces, especially for people who never. No. I'm sure in 10 minutes you can understand interfaces. It's not rocket science. It's fairly simple. So let's just give it a chance. Maybe they started from a very top-down approach, and then we're gonna get it in 5 minutes. Let's see. So that's not a great lesson. Okay, interfaces are implemented implicitly. A type implements an interface by implementing its methods. There's no explicit declaration of intent. No implements keyword. Implicit interfaces decouple the definition of an interface from its implementation, which could then appear in any package without pre-arrangement. Okay, is that very good description, explanation? Probably not. Let's see. Type I interface has M, some function M, some method M that has no arguments. Then we have the struct S. And then what do we have here? So we have a function T. So this method means type T implements the interface I, but we don't need to explicitly declare that it does so. Jesus fucking Christ, man! It's so cryptic when I read this that. Look, it just, by implementing these cryptic acronyms, it makes no sense. It's not helping anybody. There's no person on this planet who reads this fucking shit, regardless if you are an expert in everything, right? It's so bad, right? ST, like, what the fuck, dude? Like, provide a meaningful thing for people to fucking read, man. It's not that difficult. Okay, so we have an interface called player. it has a method called shoot. Exactly. Then let's create some examples. So we have a player. It has this. And let's have a. Can I have another type player here? I guess I can't. So let's say evening friends. So let's do we really need to have a struct? So let's say here type I don't know yeah, maybe like that, shooter, right? Yeah, I like that. And then yeah, let's say type player struct, right? For example, let's say name, right? Can we do something like, wait, what is the syntax now? So let me get rid of this fucking crap, man. And also this. All right, let's do something with this. So what do we have here? What the fuck is this, right? Let's just discuss this for a little bit, right? Let's just discuss this a little bit, because I don't think that it's clear for most people. And I was just struggling a little bit with the syntax. I need to get used to this syntax, right? So what is an interface, right? First and foremost, the core question hasn't been answered in this thing so far. So an interface basically is a way to describe what something has to implement, not to how to implement it, right? So in this context, we have an interface called shooter, and you will notice in Go, I think, if I remember from a very long ago, I think idiomatic Go is that all of your interfaces end with ER. So footballer, player, I guess, is a doer. So whatever. So most of the interfaces you're gonna see, at least I believe, if I recall in Go, are gonna end with ER, right? So that's basically some, let's call it an entity of some sort, right? So, but anyway, interface describes what something should implement, not the details of its implementation. Reader, sender, loader, writer, right? So you're gonna see when we start building APIs, you're gonna have a writer, you're gonna have a reader, right? So it always ends with ER. But the whole point of an interface is to describe what something should implement, not how it should implement it, right? So what this shoot does is it's irrelevant, right? So this shoot, what this does is relevant, right? You're just saying that some type or something should implement certain things, and they must implement them, right? Why is this useful? Well, this is useful because, for example, so why is this useful in Go, for example? Well, you're gonna see that this is very useful, for example, when you start implementing, when you start implementing, let's say, database clients, right? So, for example, you could implement a database client in such a way where you say, well, no matter the database client, the client itself should have this connect method, right? Disconnect method, query method, whatever. This way you can, just like you do in clean architecture with dependency injection and stuff, this way you can create interfaces in such a way where you can abstract away implementation logic, right? It's very different, right? It's very different because struct is a type that defines almost like an object. It defines the structure of your data in that sense. So if you create a struct that has 5 fields, that it's almost like a table in a way, right? So struct defines the fields that structure has. Interface just describes things that something should be able to do. So a shooter should be able to shoot. A footballer should be able to, I don't know, play with the ball or whatever. You get the point. So interface describes what something is able to do, right? So this is kind of the separation. So structs and interfaces are different in that way that a struct defines what what's in your object, which fields it has, right? Not an interface describes. So the difference is, for example, you might ask, well, it's just two different things. One is a type that defines your data. Another is defines the ability of some structure to what should some structure actually implement? What should it be able to do, right? Does this help? Let's actually let's take a look at the chat. Oh, beautiful. Let's take this example. Somebody was very let's go here. Thank you. All right, so let's see what we have. We have a shooter that has a shoot. We have an NPC, which is an empty struct. And then here we have, this is great, thank you so much. Then we have a function receiver, I guess. So we have a function that takes the P player and implements the shoot, right? And then player shoot, then we have another stab, right? If we create a shooter. Now, what happens if we do this? So this is just an interesting thing. So let's maybe the way to kind of get it is to remove this, right? So you can see now we're getting errors. This is maybe a little bit a reversed way to get it. So you can see now where it's saying, hey, well, shooter has no field or method shoot, right? So basically we're trying to implement now a shoot method which is not part of the shooter interface, right? So this is a way to the objects properties versus attributes. No, but I think if we're still talking about uncomment line 34. Yeah, exactly. So you can see the stab itself. So let's see what's actually happening here. So we have the player struct, yes, P player, stab. We have, what is the S in this context? S is a shooter. Yeah, exactly. Yes. Now add, so that's what it is. So let's see now. So we have a shooter now, which is an NPC. What is an actual NPC? Where is this crap? NPC. We have another struct NPC. Yeah, and of course the NPC is missing, I suppose, now the stab, right? So I guess here in this context, right, would also need stab here to fix it, right? So basically, the interface is the kind of rules, method names and params, and if it's having those methods, which, I mean, look, so the interface, so the way that I at least think about interface is very simple, right? Interface is your type, or to say, interface describes what your structure can do, which functions in this context it can call, right? So it doesn't define how the function should be implemented or anything like that. It just said, hey, this guy, this type is able to call this and this and this and this, right? So it's just defining what something can do, right? Not how it can do it. It's what it can do, right? So, and I think whoever wrote this example, again, thank you very much. We have a shooter here, and we can see that the shooter itself can do these specific things, right? The reason, again, but I think it's very difficult now to reason about this is because the logical question in this context would be, yes, we can do that, but just I think the reason why this is still slightly confusing, right, is because we haven't spoken about like why use interfaces at all, right? Because we haven't spoken when we talk about if we would speak now about clean architecture, or if we would speak about dependency injection and things like that, I think then interfaces are logical and they make sense, because again, then you can write code and say, hey, well, this piece of code expects this to exist. It doesn't matter. So again, as I was saying, let's imagine you had a client, you had a database client, but you wanted to abstract away you wanted to keep the same interface, but you wanted to abstract the logic. So let's imagine you have a MongoDB and Postgres, but you want to have a unified client on that. No matter what, you always have the same methods on your client. So instead of having 3 different database clients like MongoDB client, Neo4j client, Postgres client, you have a client that implements a specific interface. And then as soon as you adhere to this interface, you can implement, obviously, these methods for different databases, but the interface remains the same, right? But let's see if they actually have. So again, these examples are not very good. These examples, in my opinion, are not very good. All right, let's read. Under the hood, interface values can be thought of as a tuple of a value and concrete type. Value type. An interface value holds a value of a specific underlying concrete type. Calling a method on an interface value executes a method of the same name on its underlying type. Right. So easy to understand, right? I think that's why we have to start building things, right? But again, yeah, it's a very meaningless examples, which makes this concept, which is fairly simple concept, it makes it more complicated. No. There's no. It's just not a very humane examples. There's a lot of these acronyms, right? You have arbitrary things which don't help. Additionally, when you learn, like. You first have to decipher what these acronyms are, if they're anything in this context. They're nothing. They're just an I, interface, T, type, right? Good evening, Neo. What's up, friend? So anyway, let's see what's new to this example. Func FF. What's their float number? Okay, but let's write this a little bit together, right? So let's stop just here and let's write some interface again, right? So let's try to humanize this. Let's try to take these things and humanize them. That's what we're trying to do in this stream, right? So okay, so let's say type. Let's say. Let's say let me try to construct something out of my head. No, I mean, I don't think this has anything to do with six footfall. I don't think this has anything to do with juniors or seniors. I've been writing code for 20 years. It's not about that. It's about this can never be an excuse. There's no such thing as a senior documentation. Documentation itself or any explanation should always be as simple as it can be. It's not that the acronyms, you can be writing a code for 50 years. It's not that you read an acronym and it just logically makes sense. I don't think there's space for that, right? There's never an excuse to not write an example in using fruits, bananas, cars, dogs, something meaningful, because again, you want, no matter what type of tutorial you're writing, no matter what you're trying to describe, I guess it's always just better to remove any additional overhead for a person's mind, right? Yeah. So I'm just gonna try to keep this simple. So let's say here that we have let's try to So I'm trying to really now humanize this. Let's just use that word, humanize, because it's not about, it's about finding tangible, real examples of things, right? It's not even, you can understand whatever, every mind works differently. It's just to understand the concept, you need to put it in perspective. Like, interface is not something abstract, like something that you're gonna use somewhere in some abstract sense. That's the problem, right? Like, just for example, this is a great example, right? And this is a great example because this typically, in, let's say, when building APIs, when reading from a file, when writing to a file, when working with a system level things, you always gonna have some writers, some readers, some interfaces like this, right? Which you can instantly attach your brain to and say, well, I have some reader, I have some type of some sort that needs to implement this interface, and it needs to implement this thing, right? This method read, right? So now if we actually come here, we can hopefully we can also, let's say here, type and let's maybe actually even do this. No, that's not what I want. No. And what could we now implement? Let's try to let's now try to create some struct, I guess, of some sort or some type, whatever. Let's call it I don't fucking know. Let's call it I don't know. I don't know, right? I don't know if this is a good example, right? I don't know if this is a good example, but here we're creating some type IO, input output, and we're saying, hey, input output should implement a function called read, and this is now arbitrary, right? Here we would actually implement some, obviously low level or some file system methods, whatever. But here you create an IO object, let's call it like that. And then we're saying, hey, well, IO should implement a read, and then we define what that is here. So if I actually do this now, it's not gonna do much, right? But if I do fmt dot this, right, we're gonna get hello world. So basically, what are we doing here? So essentially, you create some type, and then you tell it, hey, where did you specify that IO struct is utilizing a reader? I think so. So that's what I think is implicit in Go 369. I think that's what we read in the documentation. I think you don't explicitly. There's no such thing like implements in Go, as far as I know, in this context. So there's no such thing. I think what you would maybe expect is to say something like IO struct implements or whatever, right? Like reader, right? I guess that's what you're asking. I don't think that the Go has that. It's implicit. At least that's what I understood, right? So as you can see here, I don't actually have to do that, because once I do this, the IO is then the compiler, I guess, implicitly is going to figure out that this read is actually coming from the reader interface, right? Please, some Go guru here can correct me if I'm wrong, but I think that's how it works. So there's no explicit way to say IO implements or whatever certain interface. I would expect so, Numinix. We can figure that out together. I mean, a lot of these, I don't know these details. I'm not, I know some Go, but that's why we're also learning it together. I don't know all of these details, right? So obviously I have a lot as well to learn with you guys, right? But that's the fun of it, to kind of, to also for us to form opinions on the things we like. And I agree definitely that not having explicit way to say, hey, this type should implement this interface, I do agree 100% that that's not really good. It's not clear enough, right? Because the problem is, right, as somebody said, is that what if you have two interfaces which implement the same method, right? Same function. How does it, like what if this guy had read as well, right? But then this read had a different signature. This read didn't have this, right? So what is this then implementing, right? Which one is this implementing, right? It's implementing, it seems to me, the first one. But if I comment this out, right, then it's implementing what? Yeah, this is a little bit weird, right? Like, why would this even work? I would expect the compiler now to complain because the read here in the writer interface, the read doesn't actually have the same signature, right? So why is this not complaining now? I think that most of us here, when it comes to Go, are not experts, so don't, right? Of course that they matter. That's what I'm saying, right? So why isn't this read now? So where is this read coming from? Isn't it coming from the writer interface now? Because I literally commented this out, right? So isn't this read now actually coming from the writer interface? Or maybe it comes from the IO which implements it. Ah, I see. All right, wait. I see. So essentially, okay. No, I get it, right? So essentially, wait, are you saying that? Wait a minute. So if I do this, I see. Okay, I see. That's so weird, man. That is so weird. So freaking weird, man. So fucking weird, man. That makes so little sense. Wait a minute. Okay, listen. So let's just make sure that I understand this, because I obviously don't, right? I have one. Let's say that I have this interface reader, right? No. I don't think Go is weird. I think we just suck at it. Still, we pretty much suck at it. It's fine, right? We will unsuck ourselves. That's why we're here. I want to make sure to say that this IO thing implements this reader interface, right? So what am I doing wrong here? No, I want to make sure that this thing no, look, I don't think that. No, I don't think that you're. I mean, look, I don't think that this is how interfaces work in any other language. So again, there's too much implicit shit going on here. That's what's not clear. There's too much stuff that's too implicit here, right? Because as far as I understand, if I do this, right? Now this thing is going to assume, I suppose, that we are actually implementing the reader interface. Am I correct or am I wrong? In simple words, do I have to implement the signature of the method here the same as I'm doing here? Is that how it works? Because if we go back here, right? If we just go back over here, a type implements an interface by implementing its methods. There's no explicit declaration of intent, no implements keyword. Implicit interface is decoupled the definition of an interface from its implementation, which could then appear in any package without prearrangement, right? So isn't that what this thing is literally saying? Right? Isn't that what this shit is saying, right? Literally, so I am in a way right? The reason now I see, man. I'm an idiot. No, I see what I'm missing. Right? So what I'm missing, it seems, here is that I didn't assign a type to IO. But if I say var IO, and then I say reader is equal to this. So that's what we missed. So that's where the confusion came from. My bad, sorry. So now it's actually good. So now if I kind of omit this crap, the IO is going to complain, right? So that's what we missed. So sorry, there's actually no confusion. This is fine. There's nothing strange about this. The only strange thing, though, is that, yeah, the syntax is a little bit strange, that you have to that there's no implements or there's no explicit way, right? And that's what they're saying in here. So I get it now. I get it. So it would be false to say, honestly, that, hey, isn't this how it works in other languages? I don't think so. No. It doesn't work like this in other languages, right? Because what you fundamentally do, you're duplicating this, essentially, so this obviously has to match. That's all. I'm fine with that. If this is how it works, I'll memorize it. It's okay. It's just we actually lacked the reader interface here, right? So that's the problem. So it's okay. It's not completely implicit, which is fine, right? So if I had another interface here, well, in TypeScript you have the implements keyword. You don't have an implements keyword here. So if I had a writer here, right, essentially it works the same, right? So that's good. So okay, I get it now. But if we say IO type, what do you mean? Do you mean if we say this? But I guess I get your question, right? But in this context now, right? I mean, but the thing is, right, now we're not implementing the interface, right? I guess, right? So now this still works because we still have this read thing in here, right? So now it's a little bit different, right? So now you just have a read method defined on the IO, right? So that is the difference, right? You get what I mean? So right now, I mean, obviously this works because there's nothing strange about this. Now we have a function receiver. We have a method that we are creating that we defined on the IO struct, and we are calling that, right? But now we're not expecting. There's no interface. We're not using an interface type here, so we would not expect this to have, right? Can you create an array? Yeah, we can try, yes. So let's do that. So you want the array of readers. So you want the array of readers. So you want to say something like var, let's say readers. And let's fmt. Yeah, actually that's not what I wanted to do. Well, if I leave it as IO, it's most likely, as we just saw, it's probably not going to work, right? So if I leave it as IO, let's see. Yeah, actually, we can use a range, and we try. Let's see. Lucky number 13. Sako, my friend. Okay, let's see what's happening. So we have the reader. And the reason why this works now, I think, is because the read has this same, right? So if we... so let's see. So we're saying var readers create an array of readers. And this works, right? The reason why this works, again, is because the read here has the same implementation as the reader interface, right? If we would get rid of this, then it would no longer work, right? It 13 months. Saku, we should, when I'm back to Copenhagen, we should hang out, man. So does this, like, are we on the same page now? Well, if you comment out the reader interface, then the compiler, it's not, I suppose, not going to be able to find it, right? Right? So what is to decipher from this? I think those are some super good things that we tried, right? What is to decipher from here is that this was a very good question, right? This was a very good question. We created the a variable of readers, which is an array of reader interface. Well, it's an array of things that implement the reader interface. And then somebody said, well, what then happened when you if you assign it this IO thing, right? And it seems to be working as long as that thing that we're assigning has the same, as long as it implements the same methods in this case, right? So we saw that even though this is an IO, it still works because it implements the same thing, same signature exactly as, right? Is that good? Maybe. I don't know. Should we spend more time on this? Should we spend a little bit more time playing with this? Anyone else has any things that we should give it a shot, that we should try? Yeah, great. Return types, yeah. So basically, the whole signature has to be the same. It seems to me, right? Does it work if we don't implement all the methods in an interface? Let's see. It doesn't. I'm sure that once we actually start, right? Look, the only way to kind of fully internalize this, and it's not really hard. It's fairly simple. Is once we actually start building things, I think this is gonna become second nature, right? So I don't think it's just when we isolate ourselves to arbitrary examples like this, it becomes slightly bit maybe tangible or logical in the pragmatic and practical context, right? But it's good to kind of see these details and how they work. But even if we stumble upon some of these issues when we start building things, it doesn't really matter. We're gonna kind of take it on the spot, right? Okay, let's take a look at this example. Interface values with nil underlying values. In the concrete, if the concrete value inside the interface itself is nil, the method will be called with a nil receiver. In some languages, this will trigger a null pointer exception like C++, but in Go, it is common to write methods that gracefully handle being called with a nil receiver. Let's actually see what this is. What is describe? Where is the describe? Okay. Okay. So what do we have? So we have this cryptic shitty thing. We have an interface called I that implements M. We have the struct T, which has a field of S. Then we have function receiver, and the T itself implements M. And we're saying here if the T is nil, return, otherwise print. And then let's see what is the meaning of this. So okay, I see what's happening here. So basically, I suppose that in this context, the T is going to be nil because we have just created an empty pointer, basically. So we have initialized the variable T that's of type pointer. I guess I'm just gonna think out loud, but we didn't basically assign T to anything, right? And because we didn't assign it, the pointer points to nothing, so the pointer is nil. And then here we call IM. So basically, okay, I see what's happening. So think about it this way. Imagine that you tried to call a method on a JavaScript object, but that JavaScript object didn't exist. It was undefined, it was null or whatever. And they're basically saying in Go, you still are actually able to call this. It's not going to give you an exception because apparently Go will handle this for you. So in simple words, you can see that we're trying to call, okay, I think I get it. So we're trying to call the M, where is the actual T? So I don't know why they do this cryptic reassignment like this. It's so fucking annoying, man. But anyway, I points to T, which is basically an it's nil. And now I think we're trying to call M, but the actual I is nil. So it's almost like in JavaScript, if you would try to say undefined dot something, right? Dot M, right? Or if you try to say null dot M, right? That would explode. You would get an exception, right? Because you can't do that. And as far as I understand in Go, it is common to write methods that gracefully handle being called with a nil receiver. All right, so I guess that's it. If I'm run it without the nil check. I see. So basically, it's gonna be a panic. It's gonna exit. Basically, it's gonna be it's gonna just shut down your app. I see. Okay. Yeah, exactly. So it's a basically SIG term, right? So it's very radical about it. Okay, I see. I see. So and with the actual check, I see. I see. All right. So essentially, yeah. So if thank you very much for that, server her. So yeah. So we're doing a check here. We're saying if t is nil, return. Otherwise, print t.s, which is basically a value on that struct. So this is fine, right? So, but it seems we do have to safeguard ourselves against actually calling this on. So, but if we actually didn't have this, right? It's gonna work, right? So basically, the panic basically happened here because we tried to say nil dot s, for example, right? And that is the problem. Okay, cool. Nil interface values. A nil interface value holds neither value nor concrete type. Yep. Okay, let's see what's happening here. So again, we have variable I that implements the I interface. I isn't really initialized to anything, right? And then we try to call I.m. So let's actually see what happens here. It's quite an interesting example. We get a panic. And we get a panic because exactly of this previous example that we had, right? But I think in this specific context, we have the actual I that doesn't really have the M implemented at all, right? So calling a method on a nil interface is a runtime error exactly because there is no type inside the interface tuple to indicate which concrete method to call. Yeah, this exactly. It's clearly the Hispanics, right? Because this thing it's actually a little bit weird. So this is of type I, right? And I suppose that if we would yeah, but I didn't want to create a struct, so it's fine. I just wanted to see. So this is a type of I. So this implements this thing. So the I implements this interface, right? But I don't see. Yeah, but I don't see where we're actually. So this I has to then implement the M, right? So that's the problem now as well, isn't it? Right? So we didn't define a method on the I thing, on the I variable, right? Yeah, exactly. That's exactly right. Because over here, right? We yeah. So we would need to do something like, yeah, exactly. Yeah, something like this, right? Then we would have to say no, that's not what I want. Then we would have to say, what is it? What did I want to do? Yeah, right. And then here, basically now, right? We should be able to do something like this, right? Yeah, that's what I wanted to do, right? So it's fine, right? It's okay. Yeah, water bottle, exactly. Okay, I get it. I get it. All right, cool. The interface type that specifies zero method is known as the empty interface. An empty interface may hold values of any type. Every type implements at least zero methods. Empty interfaces are used by code that handles values of unknown type. For example, FMT print takes any number of arguments of type interface. Okay, very interesting. MongoDB bottle. It's in Copenhagen. How could you leave it? I mean, you guys got me there. Not loyal to MongoDB. Fuck MongoDB. All right, so yeah, I can't make much sense of this right now, personally. It makes sense. FMT print takes any number of arguments of the type interface. I guess Nurko probably, yes. It's a little bit weird, yes. It's probably not any. It's maybe related to args. So in the function context in JavaScript, right, this would be probably more close to args. You know, you spread the arguments, right? But yeah, it's a little bit weird, right? But I get it. I get that there's a use of this in certain scenarios like this one, right? But it's, yeah. Var I any. Oh, I see. Okay, so it's basically like this, right? Okay, that's kind of better, right? It feels a little bit dangerous, but I guess there is 25 gold, my friend. Good evening. So yeah. Exactly. There's type any. Okay, got it. Yeah, so basically we can replace this with any, right? So that's what it is. I somehow doubt that Idiomatic Go is really open to this suggestion, but I guess in certain times this is right what's needed. You said if you would use typed language, you would fully type it and not. Exactly. Well, I mean, I would, and I'm sure that the Go community does that as well whenever possible, and I think it's possible in 99.9% of time, right? I don't think that anyone is very openly saying let's just use any everywhere, right? That would it's this is not about convenience. This is about simple logic, right? So, but it's just a utility, right? I mean, you have so many utilities in so many languages, right? And that's okay. Sometimes you need them, right? Sometimes you. I mean, I can already think of several reasons why any could be useful, right? It could be useful in certain scenarios for migration reasons. It can be, right, but it's not to say that it's something that you should use. Just because a tool exists doesn't mean you have to use it, right? I'm sure that there are many other shitty features in Go and in many other languages like JavaScript and C++. There are many features in C++ pre-dictating version 98 and before that you would never want to use again, right? But you can't obsolete the features because you would break backwards compatibility, right? So okay, let's see. Some of these things are very weird, right? So let's say here type I any. Okay, so let's leave that there and let's read this. A type assertion provides access to an interface value's underlying concrete value. The statement asserts that the interface value I holds the concrete type T and assigns the underlying T value to the variable T. If I does not hold a T, the statement will trigger a panic. The Test whether the interface value holds a specific type. A type assertion can return two values, the underlying value and a Boolean value that reports whether the assertion succeeded. If I holds a t, then t will be underlying value and OK will be true. If not, OK will be false and t will be zero value of type t and no panic occurs. So let's see this. Very weird, right? Exactly. Yeah. Numinex, my friend, I love you, dude. Thank you for coming as always. So we basically do an assertion here. Is I a string? Then we use the second argument here. This is obviously an optional name. You can name whatever you want. Whatever you want, but I guess Go, idiomatic way in Go is to call this OK. I guess that's what Go community agreed on. And then we have the OK here as well. So essentially, let's take a look at this. So if I comment this fella out, right? Oops, that's a little bit too much. So if I remove this stuff and we run this thing again, everything's fine, right? If we try to run this without using the OK, we get a panic attack. Let's call it like that. This is useful and it can be useful. Is this sort of stuff that you do all over the place? Not really. But it's in these instances when you use any, I guess. I don't necessarily think it's only in these instances, right? Because technically it doesn't really matter, right? Even if this had any type, right? Let's imagine that we had a no, let's say type foo struct. Let's test this a little bit together. Let's imagine that this thing had a var string, and let's just say here var foo is equal to something like this, right? So I am not used to the syntax yet. Jesus Christ. What am I doing wrong? Oh my fucking god, sorry, my bad. You're absolutely right. Yes. Alright. Jesus Christ, man. Come on. No. What the No, please, of course, post. Yeah. What the fuck is happening, bro? So hard, man. This is so fucking hard, dude. Oh my fucking god, man. Yes. Jesus Christ, so hard. Okay. Okay, let's test this. Oh, this has to be an interface, of course. I see. Okay. Want to play shell games with you. Exactly. I see what's happening here, right? Okay, so let's say here, interface, no. Type, full interface, no. What the fuck was it, man? Oh, this has a Jesus Christ, man. Sorry, my bad, my bad. I just fucking don't know the syntax, man. Oh my god, man, my brain is just shifting to other languages. I'm sorry. Yes, we need to implement it, of course. Yeah. Let's just say fucking name string here or whatever, some shit. Alright, cool. So let's just try this now. This what I wanted. This is what I wanted to try. So what are we actually getting here? So if we go to their example over here, right? So they had something like this. So let's just compare it, right? So we get over here. If we just move this fella actually there. So let's say here J, right? And let's get over here and say J as well. Okay. Okay, so so yeah, I'm just thinking a little bit here. Yeah, I mean, I was, but well, I actually don't know what I was trying to test. I'm just thinking about I'm just trying to figure out if there's any other instance in which you would cast things like this, other than when an interface here is any, right? Because technically, right, if you don't do this, if you just actually say in this context, wait. So if we just simplify this example again, right? So if I don't do the casting here, right, and we print the actual I, right? No, the thing is, right, what is the difference, right? I mean, look. So, wait. Yeah, well. So what is the difference now between the two, right? That's the confusing part for me now. So we have casted this J now, right? The string, right? But you can see even if we don't cast it, we're still getting hello, right? So I don't actually understand here what is the point? Why did we cast this thing? Any is generics and not an empty interface. So you're saying that any and interface are actually not the same. Is that what you're saying? So any and empty interface are not the same thing. Is that what you're saying? After you cast it to string, you can use it as string. I see. And you're saying I can't use this. Okay. All right. Wait. So are you saying now that I can't use? I see. Wait a minute. Let me just. I need to play with this a little bit from my own mind, right? Just to actually see the tangible thing in here, right? Because this is not sufficient. All right. I see. Okay. I see. All right. Well, no. I mean, look. I mean, so this example obviously wasn't sufficient for me, at least, right? Because the example that they provided didn't illustrate. It didn't illustrate this, right? So you're absolutely right now that when I cast it, it does actually become a string, right? The biggest thing is that the print line, as somebody just maybe mentioned now, maybe the print line was actually doing something internally, right? It's just, yeah, you can see that indeed now it says you cannot use J variable of type interface as a string value in this. So this now makes it more apparent what's happening, right? So indeed, yes, we have to cast this, right? For example, to a string here in this case, right? And then if we try to cast it to something else that the value of this isn't, then it's gonna panic. So I get that, right? It's just the example wasn't clear enough to me, because printing those two things yields the same result, right? But I get now that it's just probably the print, the format thing is doing something, just so maybe the output we're getting is right. I get it. Okay, cool. So for those Go people who are maybe working full time in Go, how common is this, right? So how common is it is in your code bases right now that you cast things like this? I just want to hear some opinions here. Anybody? I mainly mean, I know that casting is common, but I mean just in this context like this. From the error interface. Got it? Okay, I think one of the next lessons is the errors. Yeah, I mean, it feels awkward, right? Jesus Christ, man. Okay, got it. All right. Well, anyways, so it's good to know, right? It's not rocket science. It's pretty simple. It's just more about the application, how common it is to. And I'm only being very specific. I'm only referring to lines like this. How often will you actually get something of type empty interface, and then how often? So, and when these actual things occur, is it from third-party libraries? Is it, right? Because I'm sure that you wouldn't write the code like this, right? I'm very sure of that, right? So it's more because this looks incredibly strange, right? All right. Well, yeah. All right. So let's continue. I get that now. Thank you. What a break of a little bit. Why a switch statement now? That's so strange. I see. Okay, actually, no. This is interesting. I want to see this. All right, that's actually good. Let's take a look at it. Great. Okay. So we have a function do that takes an empty interface. So this is fine, right? I get it, right? I see. Okay, so this is a useful utility, right? So that this is cool, right? This is fine, right? So let's see. Okay, so basically, since every type, I guess, in Go implements the empty interface, right? That's what it seems to me here by reading this code. This type is going to be inferred in some way, and then based on the type that gets inferred, right, we're going to print something. So this is going to be an integer, a string, and a boolean here. But it seems to me that the booleans don't implement the empty interface based on this, right? Because I would expect that there was a case here for bool, right? I guess, was it bool, right? So it actually does. So bool. So I don't actually. This is a little bit weird that they didn't implement it. But let's say println. Oops. Println. Yeah, and then a floating point number, right? So let's say here 4.2. Yeah. No, but I mean it's okay, right? I'm not interested about the switch statement. I'm interested about the. So okay. So is it safe to say, server horror, that every type in Go implements an empty interface? Nurko, you can send it. I'm very happy to help. Okay, great, good to know. Okay, I see. So this is kind of all right. So basically, yeah. Okay. Yeah. Let's just help Nurko for a second. Let's see. Okay, Nurko. What is the question? Type something where? But when you say type something, type where? Ah. Oh, I see what you're doing here. Okay, I see. All right. Yes, I get your confusion. Yeah. Okay, sure. Well, first and foremost, right? Set count is asynchronous. So in this context, a setting of okay, look. So set count, your hook here. This is an asynchronous call, right? So this is not synchronous, right? So first and foremost, right? But that's not the problem in this context anyway, right? So your problem here is I mean, multiple things that can be improved here, right? You also want to let's just create another effect here. And let's just listen to the count, right? So as you can see now, the output is different, right? Now, of course, this handler that you added in here, you should probably clear it out also when when this thing when your component unmounts, right, when the component is removed. But this example doesn't really have that. But generally, you wouldn't define this like this. You would create some sort of a handler function, call it, const on key press or whatever, or on key down, right? Then you would define this callback like that. You would do this, right? Do something like this. You would assign, so you would have a named function in here. And then you would return here, and you would say, because every use effect, if you return from it, it's a cleanup thing, right? So here you would say document.remove, what was it? Ah, shit, where we need to return a function from here. So here you would say document.remove event listener, and then you would say on key down, right? And then you would also say, basically the syntax is more or less the same, right? So those are some optimizations, right? So when your component unmounts, you want to remove the handler. Now on key down, I don't know what you want to do on key down, right? But in your context here, the reason why the count is 0 is because you're not providing the dependency here to the effect itself, right? And also we could yeah. Does this make sense? Status Howder. Good evening, buddy. So I think so I guess your question now is why the count here is not changing. The count is not changing inside the closure of event listener. Well, this is not a closure, this is a callback. What do you mean closure? Which closure? And again, I mean, look, you're printing this count on key down in here, right? It closes over count. Which count? Well, no, no, this is not a closure. The closure would be something like this, right? This would be a closure, right? This would be a closure. And if your count was defined in here, right? So this would be a closure, right? This on key down doesn't close over this thing, right? Right? But if you wanted this value to be printed here as well, right? You would need to provide the count to this use effect, right? Let me try to provide a better example. Sure, I'll keep this open. Okay, let me just go back to this. So I get this, right? So I understand this thing. A type switch is a construct that permits several type. So the problem with so in the context of React, right? This is rather a React constraint rather than a JavaScript itself, right? The use effect thing is obviously asynchronous, right? Set count is not synchronous, it's asynchronous. You're gonna schedule some things to happen, and then your state is gonna re-render. And when the actual so I mean technically, right? Like as Leo was saying, right? This set count in here as well, right? This set count as well takes the previous state or the current state, right? So you can say previous state, and then here you could say, you know, return previous state plus whatever 1, right? And it's a little bit hard to write inside of this shitty little thing. So let's try that again. So say previous count. Here you could say previous count plus 1, and then here you can say console log previous count, right? So now if we actually set this thing, you can see what we're actually printing. You can see now that your actual count in closure actually changes, right? And actually, I can get rid of this, I guess. All right, so let's go back to this. Okay, so I get this. So type switch is a construct that permits several types of search in series. So this is useful, right? Well, you're not changing the count on key press. I mean, key down is only printing count. I mean, if you want to do the thing in here as well, right? Then you need to say, you know, previous count, and then you want to say previous count plus 1, for example, right? And then technically, then, and I have most likely a typo of some sort somewhere. Where the fuck is the typo? Con is not defined. Where do I have con? I have con somewhere. Con? What? I have a typo somewhere. Why is this shitty thing? What is this? Con is not defined. Do I have a like a typo somewhere? Key down? No, I don't think we have a. Where do we have con? Should I refresh this? Let's help. Let's provide some help. Then we go back to this. Okay. But okay. So here it is, right? So now I'm pressing the keys, and your stuff is updating, right? Is this what you want? And then if this is what you want, then I can maybe explain why this is as such. But let's make sure this is what you want, right? Yeah, but what do you want on key down? That's unclear to me. What it is that you want to get on key down. So, okay, well, yeah, sure. Okay. There you go. Is this what you want? I'm pressing the keys now. Yeah, well, you need to give it a dependency, right? You need to give it the count, right? I didn't do much, Nurko. You just look. Use effect is like component did mount, right? It's essentially, if you don't provide the dependency array, it's going to execute once when your component mounts, when your component loads, and then it's not going to react to any external changes. So you cannot expect this count to be different on key down unless you tell this thing that it has changed, right? So that was your problem, right? That was more or less the only problem, right? If you omit this, this is gonna execute. So you're gonna add this event listener with the count that's set at the given point in time when this component loaded. If I say here 11, and I now start pressing keys, you'll see that we're seeing 11 in certain times, right? You see what we're getting, right? Well, there are multiple, indeed. There are multiple things to this. That's why I rewrote this a little bit, right? So you have to obviously, you have to get rid of the existing one, right? Clearly, right? Is that fine now, Nurko? Awesome, awesome. Um, just yeah. Let's actually, yeah. Well, I mean, so this really, so the thing is, this really boils down, right, to what the this really boils down to what the listener needs, right? Yeah. So the thing is, right? The thing is, your, so the thing is that your component is gonna re-render when your count changes, right? And when your component re-renders, right, it needs to needs to register this thing again, right? And it's gonna register it now with a different value. So I don't think that you can like this or dislike it from the perspective of some architectural perspective or perspective on how you look at the code, right? And I mean, you can do this also in some other ways as well, right? But I don't want this to turn this session now into a React tutorial, right? But you can add, well, it really depends where this listener is, where this is defined, right? So it depends where you define this listener, right? Um, can I add a listener on mount only, but make it have access to count whenever count? Well, you're doing that technically here, right? This is what you're doing. This is how you're doing it right now, right? But what you're basically asking, you're asking, well, can I have it work like this, right? I guess that's what you're asking, right? And what the hell are we printing? So we can I mean, we can discuss this furthermore. Just how much of this do we have left? Nurko, let's get back to this in like 10 minutes. Let's just finish this and then we can maybe break it down and see if there's a different way to do this, right? Um, uh, we can then discuss. The thing is, it's a little bit weird. This on key down, right, is basically printing the count, right? Generally, you would, instead of doing this, you would do something a little bit different. So, for example, on key down would generally, let's say, set the count, right? And then you can hook into the previous state that you have, and then, for example, increment. In your case, you're expecting on key down, you're expecting the value of counter, because think about it this way, right? Yeah, let's just spend a little bit of time with this, right? So let's forget React, right? Yeah, I mean, if you would provide the need, maybe then if you would provide more context, right? Then I think it would be more helpful, right? It would be more helpful, right? Then yeah. So maybe if you could provide us the context, then maybe we can I can maybe help you more. All right, but let's just continue with this a little bit, and then we can get back to this. Stringers. One of the most ubiquitous interfaces is stringer defined by the FMT package. The stringer interface. Stringer is a type that can describe itself as a string. The FMT package and many others look for this interface to print values. Okay. stringer is implemented by any value that has a string method which defines the native format for that value. The string method is used to print values passed as an operand to any format that accepts a string to. Alrighty, let's take a look at this. So we have an animal. Oh, I see. Okay. All right. I see. I see. Okay. Well, the difference, I suppose, is going to be that both of these are going to be printed, right? Because now we're only getting, I guess, the name, because the name itself, which is of a type string, by default implicitly implements the string interface, right? I guess strings implement the string interface, right? So I suppose that's why when we print this, I guess that's just my assumption based on what I read, we get, oh no, never mind, actually, no, that's not correct, sorry. Goofer. Leo, my friend, good night, man. I'll sleep well, dude. Thank you for being here the entire time. Let's see each other tomorrow. Okay, let me decipher this. So let's just go back to the example. So one of the most interface stringer defined by the format package type stringer interface string. Okay, a stringer is a type that can describe itself as a string. The FMT package and many others look for this interface to print values. So this okay, and then obviously I guess the FMT implements this thing, right? Okay, so the FMT implements this thing. Okay, so if we define a string on an animal, then we say that it's doing this, that this is basically the implementation of that. Okay, let's use the example that server posted. Let's take a look at that. Let's get over here, do a type dog struct, and then oops, and we need to move this to a function here. All right. Okay. String dog. Okay. So the only thing, right? I get that now we have defined a string thing on an animal. I need. Yeah, let me just think a little bit about this. Wait, so string makes animal satisfy the stringer interface. I get that, yes. return a format string sprintf name age. And Nurko, give me like 5 minutes. I just need to decipher this in my head. Now implement it with a return woof. I see. I get it. Okay. I get it. Absolutely. So essentially what you're saying is that if you define a string, if you implement this this string interface on in this case on a struct, right? On an animal struct, you are basically in this context, essentially we are changing the behavior in this context of a print line, right? Because we are re-implementing, I guess, the let me just read the comment. You can think of it as print line method as having a type check for the stringer interface. If we bypass does implement the string interface, it uses the result of the string method instead. Exactly, yeah. So I mean, this was a great example here, right? Because you can see here now when I'm using the printf, yeah, I get it, right? To the most degree, I think I do get it. Yes. And this was actually confusing, right? This was more confusing than this, because technically here it's not confusing. It's just it was weird that we're still implementing the actual thing from the FMT printing library, right? But I think I get it, right? That's why. So basically, does this mean that? So this basically means that this string thing overrides all of the FMT printing methods, print line, printf, and stuff like that, right? If you get what I mean. So if we implement this, right, string thing, it essentially overrides. So essentially, if I do here print ln, right? Is it gonna be woof woof again? It will, right? More or less, ignoring, right, some of the arguments here, like the s, right? I get that that's gonna be right. So essentially, yeah, I see. Okay. Okay, I see. I get it. So that's a little bit weird. I must say. I understand now. So I guess if I would in fact want to do this, I would have a switch statement of some sort. So basically, this is a way to almost write an abstraction. So I assume that the FMT isn't the only let's say package that implements the string. So I guess there are other libraries as well. But in simple words, if we would just isolate ourselves to the FMT and the printing shit, then here you're basically telling me now that you can kind of improve. Let's imagine we're talking about logging. Imagine that this was a logging library and you wanted to make it either more verbose, or you wanted a specific format to be printed to the terminal differently, right? You would basically do it here, right? And then you could basically, I guess, switch in some of these things or whatever you're passing to it, right? So in this context, right? Okay, I get it. I mean, okay, I'm fully with you. So I kind of get it, and I think it's useful for sure. So basically, yeah, This would be almost like this would be almost like hooking into so you know, in JavaScript, right? In JavaScript, you would have a very different, very similar crazy thing, right? In JavaScript, you know, since everything is an object, right? In JavaScript, you would, let's imagine, you know, that you would want to that you wanted to rewrite the built-in map on an object or on an array, actually. So you would say, you know, array.prototype dot, let's say, map, and then you would essentially override this thing with a different behavior. So in a way, with this FMT, for example, in this context, expecting something to implement this interface, it's not actually, it's obviously not the same. It's not even remotely close. But if we stick to the pragmatic things, you're essentially able here to as long as your struct in this context implements this thing, you can then override specific things, right? Which yeah, exactly. So not to get into details, exactly, to string really just, but yeah, you would pretty much do that, exactly, right? So you would say, you know, whatever to string does now. So in this context, yes, you would be like, you know, to string, and then you would override this behavior. So this is basically what is just. So the only scary thing to me here is that yeah, one would need to know the side effect of such a change. Like, hey, which other library is actually, you know, which other libraries is you know, using this, right? Because if I go back, actually here, so one of the most amusing interfaces to find the FMT package. A stringer is a type that can describe it. So the FMT package and many others look for the. So this is my problem, right? And many others, right? So it's like this doesn't seem. This seems a little bit dangerous, right? This seems doing something like this seems a little bit. But not really, actually, because no, actually ignore me. No, not at all. Why Chrome and not Firefox? I think that Chrome is just faster than Firefox. That's why. Even though Firefox claims the opposite, I haven't. My experience hasn't been that great. Brave. I use Brave on my phone. Yeah. And there are other reasons. As well. Yeah. All right, cool. Stringers. Okay, make IP address type implement from stringer to print the address as dotted quad. For instance, IP address should be printed like this. Print as. Let's actually take a look at that. We have some Go fellas here. Okay, so let's No, but I don't want the fucking don't tell me how to do it. I want to do it myself. So basically, add a string method to IP address, right? Okay. So basically, what we would say func. Well, fuck you. No, that's no. I mean, this is where Copilot is a little bit useless. It just solved it for me. Shut the fuck up, man. This is the only time in my life when I wasn't happy with Copilot. Yeah, well, so easy, guys. Thank you. Wow. Jesus Christ, man. Okay. Anyway, this I was about to do. This I would fail to do because I haven't worked with these printing methods so far, right? So, but yeah, I guess, yeah, this is obviously logical to a degree, right? But I guess this would actually implement it now. Yeah. This is the Google DNS. Actually, it says Google DNS. Okay. Yeah, exactly. It seems I wasn't the only one. Okay. So, but anyway, we implemented this this thing to the IP address thing. Okay, I get it. And the favorite subject of all Go developers, errors. I've heard that Go developers love their errors, especially the verbose syntax. Go programs express error state with error values. The error type of a build interface similar to format string error type error interface. Error implements the error. Exactly, sums up the Go pretty much. Well, we can actually see one exception, right? That the interface for error is just called error. So that's oof. Okay, so let's take a look at this. So we have a type my error that's of this type, and when the time and the what string. I see. Then we have a function receiver. No, actually not. I'm actually kidding. What I love about Go, right, is that, again, as I said before, errors are you think about errors as first-class citizens, right? So you are treating the error is not some afterthought of you know. I think exception handling is horrible, and I hate it. And I think that even though it is verbose, and if nil, if not nil, whatever, I get that, but it's a good pattern. It's a very healthy pattern because, you know, you think about errors. Errors are everywhere, right? It's certainly better than try-catch. It's certainly better than anything that JavaScript supports, because exception handling in JavaScript is moved to a super high level. It's too much, right? And it makes people very lazy about errors because you're like, whatever, let me just run those 20 functions, and if some of them fail, who the fuck cares? We're just gonna catch some error. So that's not very good. All right, so what do we have here? This first, we have a custom, we have a Meyer struct. This is like a date time thing. Everybody loves working with dates, right? Then we have function receiver here that implements this error thing. Then we have function run that basically returns the actual error. Okay, I mean, I see what is the point of this lesson is. I see. Okay. And I know that the Go devs love this syntax. I actually think it's also super nice, especially because of block scoped stuff. So right, so you don't. So I agree that this is pretty awesome, in fact. And this is the signature of Go, I guess. If error, and we call the run thing. And if error is not nil, print this. So basically here we're overriding the error message with our own, right? So here we're saying, hey, implement this error thing, and then this is how I wanna print the actual error, right? So it's the same with the stringer thing that we previously did with that string thing, right? Here we're just saying, hey, well, this is in fact how I want to print the error, right? And that's cool. That's pretty awesome. I think that's pretty powerful. Yeah, I think that's great. Okay. And then we have this funky run that returns the actual error, which I guess in Go can be nil or an error. Can I actually go there? Yeah. Okay, cool. Yeah. So that's pretty awesome. Actually, so I find this now very powerful, right? I'm starting to like this. I'm starting to like that. We'll see over time, maybe in a month or two, when we build a couple of microservices, when we build a couple of APIs, then I'll see if I like it. I guess documentation of Go kind of provides us the list of things that we can, under quotes, override like this or implement, and then write our own version of that thing. But yeah, I don't know. Okay, so I get that. Cool. Exercise errors. Okay, let's do an exercise maybe. Function square root takes a floating point number. Okay, what are we supposed to do? Okay, so create this type and make it an error by giving it a okay. Okay, so basically here we're supposed to say, yeah, fuck you, man. Like, yeah, okay. And then here I guess we have to say if x is less than 0, yeah, we need to disable this shit, man. We need to disable Copilot, right? But I think this is what it is, right? So we implement this type, error negative square root, which is of this. And then yeah, we if the x is less than 0, we call the function, we give it the negative number. Well, I don't like the Copilot LEO in the context of us doing the exercises. It does the exercise for me. That's not very useful, is it? I was supposed to do this myself. Okay, I see. What the fuck is this music, man? Jesus Christ. All right, cool. So that's great. So let me just internalize this a little bit. Okay, so yeah. where's the tour go? Here, method call FNT spring inside the error method. All right, cool. Okay, so this is where we're gonna stop with this. So now we're getting into the actual shit. We're getting into building things, right? So no. So this is no. So this is okay. So basically, this concludes our so this concludes the bottom up approach of things. So this is the time now when we have all of the when we have kind of familiarized ourselves with some differences in Go relative to other languages we know. And now we're basically getting into reading files, writing files, HTTP servers, HTTP library, I suppose, right? Images and shit like that, right? So so we're not gonna do this. So we're gonna stop here by the errors, right? Okay, so I think what we need to do. Well. Now I need to figure out what it is that I want us to build. I mean, we could have also started just that way, just building something. I don't think that's feasible for most people. So now we have to figure out what do we do. Like if we build an API that's very generic, Cloudflare worker in Go. I think so. I think that's a good subject, Chica. I think so. Yeah. My only concern is that that sort of stuff is simple to build, right? We could build an API now probably in 20 minutes because it's very generic. We would use Chi router or whatever, or Chai, whatever you pronounce it, right? So I would like us to build something where we can just for a couple of days code and get the syntax and everything under our belt, right? It's not rocket science. It's just Yeah, but that's too. When I say too easy, I don't mean nothing is fundamentally here hard or easy. It's just this is more about we should do a couple of streams where we just build things just to get the just to get the ecosystem and everything around. It's not about, you know, if I wanted to build a, you know, a Go API now, I could do it with using ChatGPT in 20 minutes, right? So it's more about just building something where we can just write code manually, right? Just write stuff without abstractions. Like if we use an HTTP library, right, and write a few endpoints, sure, we can do that, but it's gonna be very, so maybe we can build a blockchain with API. Yeah, I mean, maybe we can build a CLI tool, right? Maybe we can build a CLI tool or something like that for start. That, yeah, takes few arguments, does something to file system, whatever. I don't actually know. Maybe we can write. It's just we need to figure out what to build so we can, you know, use as many of these concepts as possible, right? JS runtime, fuck you, stores password log. Yeah, I mean, yeah, exactly, Nurko, something like that, right? Yeah, something like that, right? And we could even find some. I think honestly, I don't. It's very some service for program. I mean, that's of course we're gonna be building things for programmer network. That's why this fundamentally doing this, right? But before we can do that, we need to build some few things, right? So we can say that, hey, we can now write Go, right? So it's not. It's more about, again, getting to learn some idiomatic things, getting to know the community, getting to write. So it's like, yeah, just building some small things. I think. Let me just think. I think Go is good for anything, Max. At least based on companies where I worked and people that I worked with, it was very hard to find areas where Go wasn't good, right? So, for example, what we could does Golang has something like, you know, let's see something. Does Go have something like Qt, right? Like in C++, you would use Qt, for example. Fine, okay. So maybe we could you know, build something tangible, right? What the fuck is this, man? What did I type in? Okay, fine. Yeah, I actually checked this already. Is this free? Is it open source? Is it open source? I think building APIs in Go should be a natural thing, right? All right, so where's the license? Ooh, shit. All right. So it's okay. Are you drinking Rasta? Yes, yes. I'm in the Balkans visiting family. Yes, you're absolutely right. Came for the holidays. Okay, great. Okay, so what am I thinking, right? What am I thinking? So okay. So listen. So from my experience, from all these years, right? The most boring shit you can do is build something that's not tangible, something that's unusable. So I'm not looking for this GUI, you know. I'm not I'm not looking for this GUI because I want to build a GUI app. I'm looking for something that we can build so somebody can click around and see something on the screen, right? So even if we build some service, some you know, API or whatever, we still need to use it somewhere, right? So if we want to build a file storage, some shit, right? It's still better to be able to click around, or then I don't know, maybe use a right. So I think it would be fun to build something where, you know, and also I would like to know how big the bundle of it, you know. It's just this marketing scares me a little bit. This almost feels like it's not open source. Yeah, Max, but that's too easy, man. That's too easy because again, building a generic API isn't. I don't feel that. I mean, it's not too easy, right? We still haven't touched the channels and concurrency in Go and you know, Go routines and all of that shit. So there's a lot more that we haven't covered, right? We just covered some of the basic stuff, right? So of course, right. So I don't know. We need to figure out. Like, I mean, we can find some things to build. I would actually much rather try to start building something useful as well. Um, Sarajevski Kiseljak. No, this is Go. This is Go, and we will not be writing React for this. Yeah, I mean, we have a lot of stuff to finish for programmer networks. So okay, so I don't actually know. Yeah, I think we need to figure it out, right? We need to figure it out. I just feel that having something tangible like this, where we can all click around and shit, I think that would be great. And I mean, this is almost like, yeah. No, no, no. Well, no. I mean, I agree, but this is not to say that the focus of this would be a graphical user interface, right? It's more to have something that we can click around things, right? But I agree with you, right? Yeah, I agree with that as well. Yes. So no, no. I mean, look, I want to use Go programmer network. So this is not. I'm not. I've learned Go 15 times so far since it was released, right? And the biggest problem each time was that I would do some stuff and never go back to it. So now the point of this exercise now is that we actually build things, build services, especially Cloudflare, so we could use Go Cloudflare workers, right? So no, so this is not like, oh, because, so it is for the sake of using it, right? So maybe we could indeed try, because we're already, if programmer network is already hosted on Cloudflare, right? So we could try no, I mean, but you know, most services that we have at Dream Data, they're also written in Go. We have a bunch of Go developers as well, right? So no, it is different. It's very different because I genuinely want to use it, right? I think one of the most, I think one of the most asked, one of the most thumbed up questions in the history of Go was mine, and I asked this question like 6 years ago, I think. Let me try to find it. I just don't remember where the fuck it was. I want to show you that. That's magical. I heard this 1,000 times. Shut the fuck up. I heard this 1,000 times, Alex. Man, where is it? Wait. Never mind. Okay, my brain is just, okay. So I guess you could create an online chat through WebSockets plus Golang. No, shut up, guys. Now you're shitting on me. How dare you? So yeah. Fuck, we need to figure out what to do. You know actually what we're gonna do. So you know what we can do actually. So I have an idea. Listen up. So what we can do, we can use autocannon. So we can indeed build an API without using Gin or any of the frameworks. Then we can start fiddling with some database clients. So we can build a simple API, use it with Postgres, for example. Then we can do some channels and Go routines and all of that shit. Try to kind of practice concurrency. We can DDoS it using autocannon locally, and then see, maybe do some benchmarking and whatever. So I think, yeah, that's probably reasonable, right? I think that's not a terrible idea, I think, right? All right, let's come here. Give me 1 second. What the fuck? Where's the save button, man? Are you fucking kidding me, bro? Okay. Yeah, I mean, I think so. So this project is a different one, right? I want us to collaborate in this. I mean, I genuinely want us all to. I think it's gonna be fun, right? And I have no doubts that in 2-3 months from now, we're gonna be very good at Go. I have no doubts, right? But we need to build things, right? This is fundamental, and then I need to make sure that some of the next services that I build for Programmer Network platform, which the stream is generally about, are written, so I have something to maintain, something to work on, because I've used so many languages past 15-16 years, not to go further back when I was a lot younger, and if you don't have the use, if you don't use them, you just fall out, right? You get out of the community, get out of things. So the challenge isn't building something now, the challenge is rather building something that's actually used, right? So that is the biggest challenge. So basically, I think yeah. So I think what we're gonna do here is give me a second. So we're gonna create a board here, and I'm gonna try to. So we're gonna say create a simple API. Let's just add Postgres. And I've read the comment about ORM Nurko, and that actually sucks. I find it actually very silly to hearing that suggestion, like, oh, you don't need ORM. Let me actually read. Yeah, this is it. So you can see in 2016 is when I was learning Go for the first time, right? So that was what, 7 years ago, 8 years ago almost. And back in 2016, Go was very it was very strict, right? Go tools were so fucking annoying. You couldn't compile your code if you didn't put a comment. If you didn't put a comment on top of a function, right? So, and then I asked this, hey guys, I've started learning Go, and while I do want to follow best practice and follow the linter, I'm not sure how to fix these warnings, When I put the random comment about some function, I type, nothing really happens. For instance, if I put comment about types saturation struct, I get another warning, right? And then the guy answers with the most fucking useless thing. Oh, if you go to official documentation, but he doesn't even send it to, just start reading everything. He gets downvoted. And then I answer as a complete asshole. Can you just answer the question instead of sending a link to entire documentation like generic robot? And then look at the thumbs up. 1,346. I don't think you can beat this. I don't think you can beat this. Look at this. This is the most proud moment of my entire life. This is the moment when I became famous. Look at this. And then people are obviously then, yeah. And this was 2016. This is the 2016, and this is when this is when I learned Go. I actually did write some Go back then, but unfortunately my jobs since 2016 didn't really require Go, so you just fall out of it, right? You just forget shit. That's just how it is. Yeah. But that was, thank you. I don't know how the hell you found that, but that's an amazing find. I was not able to find that, actually. No, man, it was so frustrating. I remember using these tools, right? And I'm like, man, I just wanna compile something. Why do I need to type a comment on top of the function, right? Give me a second. Let's do one thing. What a proud moment of my life. All right, so let's say use Postgres client. Let's just narrow down some things, right? Learn about channels and Go routines, concurrency. Let's just say use autocannon to DDoS the API and benchmark. Completely misspelled that, right? So I don't know, but we're gonna do something like this. So starting tomorrow, we're gonna start building an API. I think I'm a little bit bored of the Go tour. But I think it was very helpful. Some of the things, so most of the things in this tour were super simple. They're basic things, but some of these things were actually very specific to Go, and that was good to see. But on the other hand, once we start building things anyway, we'll probably discover some of these things, but some of these things would be actually very difficult to discover without stumbling upon them, especially things like type assertions, right? Okay, maybe, but stringers, like this type of stuff, right? So yeah, cool. All right, cool. So let's go back to this thing. Let me do one thing. So what I'm gonna do right now is video capture. Where's my beautiful face? Beautiful face, transform, say fit to screen. Wow, beautiful face, thank you. And then I'm gonna go, because I'm abroad, I don't have my OBS setup here at all, so I'm just gonna do this. There we go, beautiful, cool. Yeah, we're gonna definitely do it open source. We're gonna do it open source because I want to learn from you guys, and hopefully So hopefully we can do this together. It's just easier, right? It's easier to do it with the community. Some of the things for some people, some of you might be super simple. Some of the things might be good for some of you to also revisit and help others. But generally, right, I have no doubts that in a month or two we'll be able to write whatever we want, right? It's not did it before, just forgot most of the things. It's been very long ago. Yeah. But I think, some of the things which are very important, right, that we really need, we're probably going to spend a significant amount of time on is going to be channels and concurrency, because, Nurko, yeah, I mean, I don't know if you need help with that React stuff still. You can send me the message again, but I think I'm gonna wrap up. I don't know if my wife is asleep yet. She probably is, but I wanna see if she's still awake. My son is gonna sleep at the grandmother tonight, so that's why I also have a bit more time. No, you wouldn't bother me at all, man. But feel free, Nurko, if you can. Also write it in a Discord channel, right? Is it good? Is it necessary to be a good programmer to build usable products? Not necessarily, right? I mean, these subjects are very complex, right? Because what is a good programmer? Well, good programmer is overall a person that's fundamentally balanced across different spectrums, right? To be a good programmer, oftentimes, especially junior developers, would think that means to write good code, right? And there is, of course, huge truth to that. Your job is to write code, but that's just one little fragment of what being a good professional is. And there's various other things, right? So when you hear, as I was saying many times in this stream, when you hear things like 10x or whatever, right? You think that 10x might be somebody who writes some majestic code, but it's not. A person that's highly valuable in an organization is considered like at Google. If they call you a 10xer, you're essentially a developer that people likes to come to, a person that's go to for asking for help, and then person who just brings a lot of value, right, to the organization. And value isn't always code, right? That is a huge misconception amongst, especially again, less experienced developers, is that value always correlates to code. And it's not true. More senior you get, I work as a tech lead in my company, and in previous workspaces I was a team lead. Your soft skills, your communication, getting around people, focusing on objectives and key results, and many other things becomes way more valuable than writing code, because you can hire younger people to write code, right? They will do most of the time good job, but knowing what to do, how, when, how to break things down, how to provide the actual value, and get around people and help people and uplift people, that is truly the skill set that takes a long time to get, right? But when you're just new to the industry, your focus is really only on the code. So you think that you're on top of the world because you can write some code, and that's. But as you proceed, as you move further in your career, you basically you get diminishing returns on your coding skills in a way, because more senior you get, more you start moving to managerial positions, right? Like for example, now at my work, I probably code less than 50% of the time. Probably 30% of the time I code. The rest of the stuff is actually helping others, helping the clients, helping my product manager, helping my CTO, right? Helping other teams as well, right? Server her, I mean, I agree with you. There's various reasons, right? There are truly people who are very valuable, right? You can make yourself very valuable in many ways, right? So I of course 10x and all of these concepts, they're just made up terms. There's no such thing as something x, right? But you have people who make themselves valuable by having good critical thinking, knowing when to do things and how, knowing what to focus on, knowing how to inspire people, how to make people driven. And this is not a fairy tale, it's true, right? I mean, That's why I say, as more you grow in your career as a senior, more these skills matter. Skills on affecting people, affecting change, and being a person that's genuinely just a person that people want to go to ask for things, right? So that's why your behavioral skills as you grow in your career become way more important than if you can write React or Golang or some shit like that, right? Because that's learning syntax of a language and memorizing how some concurrency works somewhere is just a small fragment of your work. That's fundamentally simple. You just need to spend some hours and that's it. But what's not fundamentally simple is being a person that's approachable and person right. So that is the difference. That's at least what I'm seeing in my career. All of these years, and again, further you move away from into managerial positions, CTO, team lead, tech lead, more some of the other skills surface up, and your coding skills. I mean, when I say coding skills, I don't mean architectural skills. I mean memorizing certain details become less relevant, right? And your experience becomes more important. So can you build good products without being an insanely good programmer? Of course you can. Most startups out there, that actually succeeded, that even became unicorns, their code bases initially were complete crap. And that's normal because inherently startups have lack of resources, lack of time, lack of competence, which is also why full stack exists, right? The full stack is a byproduct of exactly that, of startups, right? Do you have any any advice on how to improve those soft skills and become the person that people want to go to? Well, there's no specific pattern to that. You genuinely like it's a very good question, but there's no specific pattern to that, right? You genuinely have to seek for value, right? The thing is, a lot of people, I think there's a lot of misconception. Nurko is right to some degree, but I think there's a huge misconception. I can make a parallel here. There's books like for example, there's a book by Dale Carnegie that was translated as like how to become a millionaire, right? Like how to become a millionaire and affect people, right? And a lot of these concepts are so overcomplicated just because people like to be influenced. But in simple words, right? If you want to be a person that people approach, you have to be a person who genuinely likes to uplift other people, likes to help, right? So this is a natural thing. For example, my biggest motivation at work is helping people. That there's nothing. I have almost zero motivation to go to work because I'm writing code, right? I think that doesn't excite me a tiny bit anymore. But if I can uplift people, if I can help the customer, if I can provide some critical thinking skills to, for a Dream Data where I currently work, for example, we're doing objectives and key results, we're doing OKRs. So my team is not getting tasks put on the board and you come to work and you're like, do this task and go home. You get a business problem and then we as a team, my team consists of 5 people. We have 3 developers, a designer and product manager. And if you have read, inspired by Marty Kagan, right? You will know what I'm talking about, how products are built in Silicon Valley, for example. But this sort of work is very fun, right? You get a business problem, and you solve it as a team, and you create the tasks. You create the whole environment around approaching these problems, right? And this is very challenging, and it's but it's also very it is a great book, yes. It's just so if you want to be that person that people approach, you genuinely have to be driven by helping people. You cannot force this. So if you're not proactive, if you're reactive, you cannot do that. If you are, if you have watched some of my videos, right, on YouTube, you will notice that I often use these words: be proactive, not reactive. Don't complain and bitch about things. Affect them proactively yourselves. If something doesn't work, fix it. Don't cry about it, right? Because developers are notorious for saying things how things should be. There's countless of people for more than 1 year of streaming here on Twitch. People come and say, "Oh, why are you not doing this like this? Why are you not doing this?" While they're not doing it themselves at all, right? It's like there's every week there's a person, "Why don't you write this in Rust?" And then I ask them, "What did you write in Rust?" And they just disappear, right? So it's like, if you want to be that person, be proactive, not reactive. Don't talk about shit. Do it, right? Base your experience on action, not on talk, because talk is cheap. Everybody can talk, especially here on chat. People come and they're experts when it comes to talking, but when you ask them what have they built, it's usually nothing, right? So this is what separates people. Some people are actually actionable and they do things, and some people just bitch around things, right? They shit about things, they crap on things. They crap on languages. PHP sucks, Java sucks, this sucks. But most of these people never actually built anything in these languages. They never even tried them, right? So it's this mass hypnosis of fucking YouTube-inspired idiots who just parrot shit that they hear in random articles and stuff. And then they have no idea what they're talking about for the most part. It's just just a lack of any factual approach to engineering at all. It's just like, I heard that other people are saying that this is bad, and then I'm gonna do the same. So anyway, there's a lot of this shit. Don't be such a person, right? Be a person that finds an issue in the code base and you fix it yourself. Be the person who does well in code reviews. Be genuine and try to help. And yeah, be proactive. And if you can achieve these things in your work, you're gonna be a person that everybody wants to hire. And if you're opposite of that, just a complainer who just bitches about things without providing any concrete things, is like this article that Leo shared today, right? It's like, if you complain about something, provide a solution. Otherwise, stop complaining, right? There's no point in complaining without action. Because what are you solving? It's like, it's easy to shit on things without providing a concrete solution to the problem, right? Yeah, exactly, Narco. I mean, this is a cancer. That's why I recorded this video, right? That's why I recorded this video recently. Let me just send it to you guys. I recorded this video recently called influencer-driven programming, influencer-driven development, programming propaganda. Let me send it to you. And this is basically that sums it up. I literally summed that up in 5 minutes, right? It's a semi-hipster community full of idiots, right? Who it's almost like a video game to some people. And this, as I speak about that in this video, this became apparent when programming became mainstream. Programming maybe 15 years ago wasn't like this, right? I mean, being a nerd wasn't something people were proud of. People were usually laughed at, right? Today, every idiot, is some sort of a designer, developer, or some shit like that. And then, people form opinions based on no experience, right? You have people finishing boot camps, and then 3 months later on their LinkedIn profiles, they're senior, right? They're experts. They're teaching others. So there's a lot of absence of anything in this industry past couple of years, and there's a lot of talk. A lot of people are just shitting about things, never building anything, never putting the money where their mouth is. It's just talk, just cool talk, badass talk, like nodejs sucks, Java sucks, performance. And then you ask them about performance, and there's never a response. For more than a year in this stream, I've never gotten a response from a single viewer who said, there's like, performance of PHP sucks. And I'm like, what have you built in PHP? It's like, shut the fuck up, man. Seriously, like, it's ridiculous, right? But it is this mentality, right? It's a group mentality. It's a herd mentality, right? And people just like to talk. I guess it feels good to feel awesome, right? So you just talk shit, right? Exactly. So anyway, like, seriously, like, if you want the best advice in your life, genuinely, just be a person that does things, right? Do things. Don't talk about shit, don't complain without action, right? Be the person that's proactive, that does things, and every company will want you. That's if I'm hiring for my team, those are the main qualities. And actually, I'm so fortunate to have an amazing team of people who genuinely are so proactive. You have a person who goes to the code, finds that something can be improved, and they do it. They don't ask for permission because it's their fucking job to do it. So they don't ask for they don't delegate it to others. They don't procrastinate. Oh, let me make a task, and then we're gonna do it in 3 years, right? So if you can set yourself up to be such a person that does things and that improves things continuously in small steps, incrementally, everybody loves a person like that, right? And if you're a guy who goes to beer after work with your colleagues and you just cry like a little bitch about everything, nobody likes such a person. That person is useless, right? So this I think sums that up in the context of behavior. Ask yourself, are you a proactive person that's actionable, or are you a person that just cries about things and complains about everything without providing any context or any solution to any of the problems, right? And I think there's a lot of people like this. I met some in my career as well, and exactly. So server horror. Look, there's for sure. I agree with the premise, right? That there's certain things which are faster than others. There are certain things that have better or worse design than others. Nobody neglects that. For sure, there is some truth in programming as well. Some languages for some things are better than others. Some databases are better than others for solving problems. So nothing is it's not fully relative or meaningless. But that's not the point, right? The point is that majority of these complaints are coming from people who never actually face these problems themselves, because it's almost like it's basically some of these things became, like Nickelback band. I think Nickelback as a band is the greatest example of this very very scary thing that humanity created, right? Nickelback as a band was probably a very solid, very good band, and then somebody shut on them online on some TV station, and they became a meme on the internet. Everybody today hates Nickelback, right? Nobody actually know why they hate Nickelback, but when you read the comments on the internet, people hate Nickelback because other people hate Nickelback, right? So it's the same with this cancerous thing in programming. It's just the biggest problem here is that programming is a skill that used to be that used to be done, by people who are pragmatic and reasonable and factual and stuff like that. So programming became also a community of exactly that. People who just do some things or say some things because other people do it, right? Yeah, sure, server horror, right? But you have some experience, and you have based your opinion on some experience, and that's respectable, right? I never heard about Nickelback. I hate them now. Nickelback is not a good. It's not a good band for you. Maybe it's not a good band for me either. But your opinion doesn't define the absolute truth, man. I mean, Nickelback might be banned for you. Maybe it might be banned. Might be bad banned for me as well, right? But just because you dislike it doesn't make it true bad, right? It makes you dislike it. That's fair enough, right? That's great. But you cannot say that that might be true for everything, right? For everybody. That's the point. NSD, my friend. Good evening. So anyway, I mean, I think for me that's a simple philosophy, right? Don't talk about shit you don't know. Focus on things you know, and try to form opinions based on your own experience. Of course, you should account for other people You're just giving me some shit. Fair enough. No, I didn't catch it. Sorry. And that's how it is. I think for 99.9% of developers, as I said many times, and companies, a choice of technology is really all about ease of hiring, ease of building teams, and ease of many other things. For majority of the companies out there who have few thousand users a month visiting their service or whatever, the choice of language is all about but performance, right? I mean, if we were to talk about some of the hated languages today, let's say PHP, you have TechCrunch magazine running on WordPress, you have CNN running on PHP. There's so many websites out there that have probably millions of views every day that operate on these under quotes shitty technology. You know, PayPal.com is running on Node.js. And then you have some asshole who is living with his, grandma coming here to the stream and saying, Node.js is slow. There was actually a guy a couple of months ago on this stream. He came and he said, I remember this very well. There was a guy a couple of months ago on this stream who came here and said, I can't wait for Bun.js to replace Node.js. And I said, wow, okay, why is that? And he said, because I hate Node.js. And I'm like, all right, wow. So, and I said, why do you, so what? And I asked him, what did you build in Node.js? And he said, I actually haven't built anything in Node.js. And that was so fucking strange, man. I mean, the guy came, he said, I can't wait for Bun.js to replace Node.js. But he never used Node.js, right? And then that kind of showed me what type of kind of personas you get in here, right? The guy was completely clueless, but he, for some reason, couldn't wait for a technology X to replace technology Y that he never really used. But then I probably realized he probably went to some YouTube shitty channel where some asshole just told him how horrible Node.js is, right? And then he formed an opinion, right, based on nothing, right? And that person is calling themselves an engineer, right? It's ridiculous, right? I can't comprehend that. It's literally mentally insulting to see that type of shit, man. JavaScript has a spec, yes. JavaScript has ECMAScript spec, which is pretty well defined. I mean, look, JavaScript as a language has evolved a lot over years, right? JavaScript has gotten better year by year. One fundamental thing that people don't understand about when you're approaching any language really is that more popular the language is in some way, more garbage you're going to have in it, right? I mean, JavaScript is a language now that runs pretty much on everything. On your mobile phones, your mobile apps are written in JavaScript, your desktop apps are written in JavaScript, and so many other things, right? But JavaScript as a language is a beautiful language, right? You just have to know how to write it, right? JavaScript is a hard language as well, right? So JavaScript is not an easy language. JavaScript is an easy entry-level language. It's very easy to start with JavaScript. But most people end where they start, which is why you have a huge influx of developers who are not competent to write JavaScript. And that is the problem, and that's often what creates this disparity in quality, right? JavaScript is not an easy language. JavaScript is a hard language because it's untypical language. It's not very typical that you have a language where everything is an object. It's not very typical that you have stumbled upon a language where you have these prototypes and objects inheriting from other objects. And there's so many rules in JavaScript which are unique to the language. You can come to JavaScript with experience of 20 years in some other language and you will still have to learn a lot of things, right? So JavaScript fundamentally, it can be a great language, but you have to, sit and learn it. Now, what most people do, because it's way easier to shit on things than learn them, is they just crap on things. Because it takes a lot less effort to learn something than to shit on something than to learn it, right? So I think this is fundamentally the problem of the web. That's why today you have something called React developer. What the fuck is a React developer? You have a Angular developer. What the hell is an Angular developer, man? When did we start creating roles of frameworks like a React developer? What is a React developer, right? So what is a Gin developer? Should we have like a Fastify developer? You get what I mean. So and the reason why you have that is because you have a lot of people from boot camps, a lot of people from universities who learn these steps. Import the component, put some function here, do this, and then you learn the loop through this, right? So, right. Yeah, I mean, look, the thing is, so you know what's my biggest problem, server horror, right? The biggest problem is that people constantly talk shit about JavaScript, right? But nobody actually has created an alternative yet. So I think fundamentally, right? If all of these people are so smart, man, I mean, it's a very genuine response to that. If you have millions of people, arguably, or thousands of people saying shit like this, the reasonable response to these people would be, well, just make a language that's better and runs in the browser, right? I mean, we are still waiting for WebAssembly, right, for like 15 years now, and I keep hearing WebAssembly and cryptocurrencies share one thing in common. We keep waiting for that next year for them to take over the world, right? Both cryptos and WebAssembly. Every year is the year that these things are gonna take over, right? So there, yeah, there's a lot of, there's a lot of I genuinely believe that these people who talk this shit are usually, this comes out of absence of it's just an absence of knowledge, nothing else, right? Because again, JavaScript is not an easy language, right? I personally, I mean, I don't get attached to technology like that, right? For me, I don't hate or dislike anything. I mean, I've wrote PHP 3, I wrote Visual Basic 6, I wrote Pascal many years ago. I wrote Cobol, I wrote a little bit of Haskell, C++ professionally, JavaScript for many years. I never attached myself to a language in any way, right? For me, I'm aware that currently, if I want to build a web app, I need to use JavaScript. It's not a matter of choice. If I had 5 different languages to choose from that actually work inside of the browser, maybe I wouldn't write it. But there's no other option, right? You have to write it. And instead of complaining, what is the alternative? The alternative is that you sit and learn it, right? You learn the basics of the language, you learn how the language is built, what is it built on top of, right, etc., etc. So that's way easier. It's the same with CSS. Like for example, CSS is one of these culprits of people, because most people shit on CSS instead of sitting and understanding it. You sit for 5 days, you learn about CSS box model, you learn about display position properties, you learn some flex, you learn some grid, and then you realize that CSS actually isn't that terrible at all. There are actually rules that if you follow them up right, they will right. No, server horror, I by no means said that you are. So sorry, maybe I'm not strictly answering your messages, I'm just talking in general. So I'm with you, man. I am absolutely not stating that you're hating on things. No. I'll check private message in Urko. 1 second. Let me do that. Private message, private massage. Oh, okay. Nurko, can we do it? Can you send me that on Discord, or actually you don't have to send me on Discord. I can, because I'll need to leave soon. It's like it's like midnight here. But yeah, I think interesting discussions. I think could you review the code that I sent to? Yeah, I can review your code. Yes, absolutely. What's your local time? I don't use Discord. Got it. Absolutely, Nurko, we can do that. It is it's midnight here now. So so yeah. But I want to say to Server Horror, thank you so much for your help, man, with Go. I hope that you're gonna have time sometimes to at least in the next couple of streams to come and give us a hand, because you did speed up some stuff for us. So I appreciate that, man. Also Nurko and everybody else. I think that was pretty interesting and pretty nice. Yeah. Yeah, well, I guess let's round it up, guys. How long was the stream? I streamed 3.5 hours. Jesus Christ, man. Is that like the longest stream I ever had? It could be. I don't know. But it's usually never more than 3 hours. Okay, that's great. Okay, so tomorrow we're going to see each other again. Tomorrow we're going to actually start building some stuff in Go. I think that's going to be fun. We're going to do this in an open source way. Of course, Max, my pleasure, man. Thank you for being here as well. It goes both ways. So yeah, tomorrow we're gonna start building an actual thing in Go. So it's something that's more fun than just following the Go tour. So yeah, so that's what it is. That's what it is. That being said, yeah, Nurko and ByteLordy and Max and Server Horror and all of you guys, thank you very much. Thank you for being here. I gotta go and get some sleep. Max, I'll review your code in the morning. It's very late here. I need to run. So yeah, I hope you're gonna be around here tomorrow, Max. You can just check Slack. I'll take a look at that. Yeah. That's what it is. All right. I'll see you guys tomorrow. Have a good night. And NSD, Go, and Rust are very different languages. They serve different domains and completely different domains. So Rust is a low-level programming language for building embedded stuff. It's something that's supposed to replace C and languages like that. You would not be building APIs in Rust, at least not yet. So yeah, so that's why. Those two languages have nothing to do with each other. They're vastly different, and they serve completely different problems. They solve different problems. Go is a language of infrastructure, Kubernetes, Docker. Rust is a low-level language that you wouldn't use, especially not today with a very poor library support and stuff like that, building web APIs and stuff, right? So that's why. All right, guys. NSD, thank you, buddy, for coming as always. Always good to see you. I'll see you guys tomorrow. Peace out, fellas. Bye-bye. Just.